I am psyched. We're going to go over why the cross product or cross multiplication, why it works. Let's check this out. Cross multiplication, as we've seen before, is the idea of seeing whether or not ratios are equal to each other to make a proportion. We multiply 3 by 15 and 9 by 5. We cross multiply. But why does it work? Well, it goes off of this main principle. If you have an equation that is either true or false to begin with, if we do the same multiplication of the same number to both sides of that equation, then that does not change the truth or falseness of the equation. So that's really what we're doing when we cross multiply, and I'll show you. What we're doing when we cross multiply, we do the 5 by the 9 and 15 by the 3. What we're really doing is we're saying, well, let me multiply both sides of this equation by 5. And what happens when we do that is the division of 5 on this side that's happening in that fraction divides out to give us 1, leaving us with 3, and we're left with the 5 on that right side. Okay, that still leaves us with a 15 on this side right here. So I'm going to undo the division by 15 on the right-hand side by multiplying both sides of the equation by 15. So we can divide both sides by 15 as well. What happens on the right-hand side is the 15s cancel out completely. Ooh, what is left? We have 3 times 15 left, or 15 times 3. And if you look at this example, isn't that just this part right here? So there's a cross multiplication going on, 3 times 15. And then on the right-hand side, you're left with 9 times 5, or 5 times 9. And that is this cross multiplication right there. So we're really just using the multiplication property of equality. Again, if we do the same multiplication to both sides of an equation, we do not change the original truth of the equation. So what that means is, since the truth of the equation hasn't been changed, if this result is true, then the original ratios are either both true or both false, right? So 15 times 3 is 45. 9 times 5 is 45. That's a true statement. And since we did a property of truth to get there, that means that the original statement was true. Had the original statement been false, we would have gotten a false equation here, telling us that, again, the original statement was false. Y'all, that is really epic! How about I show you now with a little bit of algebra? So I'm going to show you this now in general. So if you're good on this part and you're saying, you know what, Mr. G, I'm cool. That was a great explanation. Way to rock it. Then go ahead, leave by all means. But let me show you for all numbers why this works. So let's say that we have a ratio A over B equals C over D. Now, B and D cannot equal to 0. I'm going to put this on the side because we cannot divide by 0. So B and D cannot equal to 0. So 0 does not equal B or D doesn't equal 0. Okay, now, I'm going to show you how the cross multiplication thing works. Well, we're going to use the same idea. I can multiply both sides by B. Again, that does not change the truth or falseness of the equation. The B's will cancel. That leaves us with B times C over there. Then I'm going to get rid of the division by D, so I'll multiply both sides by D. And so that leaves us with A times D on the left side equal to, and the D's cancel out, B times C on the right side. Well, let's revisit what we actually just did. Remember that the original ratio was A over B equals C over D. So we got A times D and B times C right there, showing you that cross multiplication is really just the result of multiplying both sides of an equation by the same number. And in this case, we multiply by 2 different numbers, and it results in showing that cross multiplication works to verify, show if something is true or not, whether or not a proportion is indeed a proportion, or if it's just a false statement. Awesome, very awesome.